Hello students, so here we will going to see the proof of the basic proportionality theorem, that is also known as the Thales theorem, or we can say BPT theorem. Yes, it is very famous, that is BPT and BPT theorem. So we will going to see the proof of that particular BPT theorem here. So before starting this solution or proof, I will going to tell you that there usually have two types of the proof. One is a very simple one, but that is depending on the similarity. But what happen is that in some syllabus, like in some state board syllabus of the class 10th and in the CBSE syllabus of the class 10th, what is similarity concept is given later on after giving the BPT theorem. So what happens whenever we have to prove the BPT theorem, so sometimes we have to prove it without using the concept of the similarity of the triangles and all. So we will going to see in that case how we can prove that particular theorem. So I have given here the theorem and I have also provided you the solution of that particular theorem. So we're going to see and learn the proof of this theorem here. So it will be very easier for you to particularly write or provide that particular proof in your exam, also in the board exam. So it is important for all type of the board classes or boards of the class 10s. So it is very important in view of the board exam, because it is frequently asked in the board exam for proof of this particular theorem. So we will find out the proof and we will learn the proof here. So let's start. So you can see there is a solution or the proof is already given by me. We have given the statement, that is, if a line drawn parallel to one side, if one line is there that is drawn parallel to one side of a triangle, and that line intersect the other two sides in a distinct point, means in a separate two different points. Okay, now this point, it is not necessary whether the two given points are midpoint of those two other sides or not. Okay, so distinct points, then the other two sides are divided into same ratio or equal ratio. What is happening here is that whenever we draw or whenever we take one line which is parallel to the one side of a triangle, and then obviously it will going to intersect the other two sides, then those two sides will be divided into equal ratio. So we have to prove that. So what I have done here, I have considered one triangle, that is triangle ABC. I hope that you can see that particular solution or the text which is written on the paper clearly. I have taken care of that much convenience. So what is given here, triangle ABC is a given triangle such that D is parallel to BC. So you can see here D is parallel to BC. So D is parallel to BC. That is one line. So what we have to prove? We have to prove that AD upon BD equal to AE upon EC. Now what we will do here, we will just do some small construction. What we have to do, we have to join the C, D and B. These are the 2 points which are given. Now because of that particular D or parallel line, that triangle ABC is divided into upper triangle, that is triangle AD, and lower part will become the trapezium, that is BDEC. Now in that trapezium we will just join the two diagonals CD and BE together. Now I will draw DM perpendicular to AC. I have drawn one DM perpendicular to AC. Similarly, I have drawn the EN that is perpendicular to AB. Fine. Now from the figure, what I get that triangle AD, area of a triangle ADE can be. Now where is that triangle ADE? You can see that is a triangle in the upper part of the given triangle, means that is upper part of the. Okay, so area of triangle ADE can be written as half base into height, that we know. Now in this half base into height, what is the base? Base is AD. Base will be taken as AD for the triangle AD, and the height will be EN, that is a perpendicular drawn on the AD. Similarly, now the triangle is same, but there are the two heights, or there are two perpendicular or altitudes. So because of that, now its area can also be written as half multiplied by A, that is a base on this side, AE, multiplied by height, that is DM. Okay, so because of that I have given it a equation number 1. Fine. Now similarly, we have given the two triangles, or there are two triangles in the below side in the trapezium BDEC. You can see so there are two triangles BDE and CED, which are based which are having the common so now in the lower part you can see that there are the two triangles BDE and triangle CE. ED. Okay, now listen me carefully. Whenever I am saying something, then you have to observe towards the diagram also, because it will be very easier for you to understand what I am saying and what you are looking for in the diagram. Fine. So if I have to calculate the areas of these two triangles, means area of a triangle BD, again I will apply the same formula, half base into height. Now what is base here? Base is again BD, base is BD. Now that BD base is extended up to the n, so I will going to get the height of that triangle, that is En. So I will write the height, that is En. Similarly on the another side, means on the right hand side, what is here? Triangle CED. Now in this again, in this triangle again, there is a EC, that is a base, so it is a base. What is height? That is DM is the height, or it is a perpendicular. So in the equation number 2 and 3, I have written down the areas of the triangle BDE and triangle CED in a conventional manner by using the same conventional formula, that is half base into height. Now we have to observe here is that in this particular trapezium, these two triangles BDE and CED are based on the same base, that is a D. They have a one common base side, that is a B, D, okay, or we can say ED, and they are situated in between the two parallels. What are the two same parallels? ED and BC. So in the 9th class we have studied one concept, that whenever there are the triangles, or infinite number of the triangles are situated in between the two parallel lines, then their areas used to be equal. So here these two triangles are situated in between the two same parallel and they have the same base, so obviously their areas will be equal. So I have given it in this equation number 4, that area of BDE and area of CED are equal, because the reason is already provided above. You can see this is the reference, or the reason is there. Now what I want AD upon BD. So for getting AD upon BD, I will observe the equations where the AD and BD are known. Now in this case, AD is here and BD is here, so I will just divide the equation number 1 by 2, so I will going to get the AD upon BD. So I have divided here the equation 1 by 2, that is area of a triangle. So I have divided the left hand side as area of triangle AD upon area of triangle BD, and on the right hand side I will write as it is this and this equation. Now what is common here? En. So En will get cancelled here, and half of is also cancelled here. So what is remaining? Only AD upon BD. So I will write here area of triangle AD upon area of triangle BD is equal to AD upon BD. I will give it equation number 5. Now this is the one pair, or this is the LHS side that I got for the proof, or for proving that particular theorem. Now what about the RHS? Now for RHS I want the AE upon AC. I will now find out the AE. Where is AE? AE is again in the equation number 1. And where is EC? EC is in this equation. Okay, now I have highlighted that portion, or I have just made the annotation, so because of that you can't able to see it clearly. I will just show it clearly. So now you can see here EC is there. Okay, so I will just divide the equation number 1 by equation number 3. So I will just divide the equation number 1 by equation number 3. So let's see. So you can see here I have divided the equation number 1 by equation number 3. So it is written here. Now area of triangle AD upon area of triangle CED. You can go back to those equations, you will going to get the idea. So again DM equal. So it was cancelled because they will going to divide to each other. Similarly half will get cancelled. So what is remaining here? AE upon CE. So I got one expression, that is area of triangle AD upon area of triangle CED equal to AE upon C. I got the RHS side, that is AE upon C. But now in the equation number 4 we have seen that this area of triangle CED is also equal to the area of triangle BD. Why? Because both the triangles, these two triangles CED and the triangle BD are in between the same parallels and having the same base B, that is a D, and because of that we have seen that in equation 4 both having the same area. So in place of this I have written just area of triangle BDE, and numerator will remain as it is, that is area of triangle ADE. So what is the expression now? Area of triangle ADE upon area of triangle BDE is AE upon C. Now this is the equation number 6. Now I will go back to the equation number 5. So what is in the equation number 5? Area of triangle ADE upon area of triangle BD equal to AD upon BD, and in the area of triangle ADE in the equation number 6 it is AE upon C. So in the equation number 5 and 6 LHS is same. So obviously if the LHS are same, then RHS should be same. Okay, so because of that I will going to equate the both equations. So from equation number 5 and 6 I will get AD upon BD equal to AE upon C, and that is the required proof that we wanted to prove here. So hence I will write here hence proved. In this way we can just prove this theorem by applying some basics of the area of a triangle and just doing some little construction. We don't require out of the box thinking here. We have to just observe the triangles, we have to just put the values in the given formulae, and that's it. Now some of you will going to find out this whole proof of this theorem is complex and clumsy one, but that is not the matter. What is happening here is that whenever you are preparing for the board exam, or whenever you prepare this theorem for proof, then you have to practice that particular proof by writing on another blank paper. So whenever you will going to try to prove this theorem one or two times on a rough paper or rough page, then obviously automatically you will going to get the idea how to prove this theorem. And already I have given you the detailed step by step solution, so again you go through this all steps. I have chosen this method to tell you because this is one complex one, or this is the one in which you people have the doubt. So I hope that this will going to help you a lot, and it will be a useful one for you. So thank you so much.